Okay, so just a line and a point on your graph. So we have line A. Okay, so instead of line L and M, we have line A containing these 2 points here. We want to construct a line perpendicular to A through P, then find the distance from P to A. Okay, so we're still finding that distance between 2 points. Okay, and in this case, we're finding the distance between the point we're given and the line we're given. So to start off, we want to graph line A and our point P. So we're going to plot these 2 points to create line A. So we have 1, 2 as our first point, and 5, 4 as our second point. Okay, and you only need 2 points to use your straight edge to connect those to make a line. My document camera is in my way for my line here. Okay, so this line is line A. So line A contains those 2 points, so I'm going to label it line A. Then we also want to graph point P. So point P is at 1, 7. And we'll label that point P. So we're trying to find the distance between that point and line A. So again, your shortest distance is always the perpendicular distance. So I want to find a perpendicular line that goes through P and connects with line A. So to do that, I have the steps laid out here. So we want to find an equation of line A. So we're given 2 points on line A, right? So we want to find the slope. Okay, slope is rise over run. So from your point, we are going to go up to 1, 2. So that's our rise. Over our run is 1, 2, 3, 4. Okay, so our slope is going to be 1/2. Okay, and that's the slope of line A. So next I want to use a point that's on that line and the slope to create an equation of this line. Okay, so it doesn't matter which point you use, one of the 2 that's in line A. So that's either 1, 2 or 5, 4. Okay, so I'm going to use the point 1, 2. That is your x and y value. And we're going to use our equation y equals mx plus b, because we want to find that y-intercept. So plugging in my values, I have a y value of 2. My slope I found, that's m, is 1/2. And this x value is 1. And we're solving for b. Okay, so we have 2 is equal to 1/2 plus b. You need to subtract 1/2. So we have 2 minus 1/2 is equal to b. Okay, to combine fractions, remember you need a common denominator. So this 2 is actually over 1. So to change that to a 2, I would multiply both the numerator and denominator by 2. So I would have 4/2 minus 1/2 is equal to b. So your b value is 3/2. Okay, so now that I have my y-intercept and my slope, I can write an equation of this line. That is, y is equal to, our slope is 1/2 times x plus our b value is 3/2. Okay, so that's the equation for line A. Next, I need the equation for a line perpendicular to line A through point P. Okay, so what is the equation of the line perpendicular to line A and passes through point P? Okay, if we're trying to make this perpendicular to A, I need a perpendicular slope. Okay, so I need the slope that would be perpendicular. So since my slope for line A is 1/2 and it's positive, I need the opposite reciprocal of that. So opposite would now be negative. Flip your numerator and denominator for the reciprocal, which is 2/1 or just 2. Okay, so our perpendicular slope is -2. Now I need to create an equation of a line that goes through point P. So in this one I have to use point P, which is at 1, 7. Okay, so I'm going to use that as my x and y value to find out what the y-intercept is. So again, we're just using y equals mx plus b, and we want to solve for b for that y-intercept. So plug in 7 for y, plug in our new perpendicular slope, that's -2, times that x value is 1, plus b. And we just want to solve for b. So we have 7 is equal to -2 plus b. Add 2 to both sides to get b is equal to 9. So now I have the perpendicular slope and the y-intercept, so I can write out the equation of this line, which is y is equal to, our slope is -2, times x plus that b value of 9. Okay, so we had to find that because we're trying to find the shortest distance between point P and line A, and that is your perpendicular distance. Okay, so now I need to see where that line that goes through point P intersects line A. Okay, to find that intersection, again, you have to solve that system of equations like we did yesterday. So I need my two equations for line A and for my line perpendicular. Okay, so I have y equals 1/2 x plus 3/2 and y equals -2x plus 9. Okay, I want to see where those two lines intersect. So just like yesterday, since both are equal to y, they equal each other. So I can set 1/2 x plus 3/2 equal to -2x plus 9. And we just solve for x from here. So I'm going to add 2x. So I am going to get a common denominator here for this 2x since it is 2/1, right? So I can change that to 4/2. Okay, so I'm still just adding that 2x on. So I have plus 3/2 equals 9. Adding these two together then, I have 5/2 x. Okay, next I can subtract my 3/2 from 9. I'm going to move up here. So I have 5/2 x is equal to 9 minus 3/2. And again, this 9 is over 1, right? So to combine my fractions, I need that common denominator. So I end up with 5/2 x is equal to 18/2 minus 3/2. And then you can subtract those to get 15/2. Okay, almost done. So I still need x by itself. So to get rid of this fraction out front, I just need to multiply by the reciprocal. So 2/5. Okay, so I end up with x is equal to 30 over 10. Okay, and I can actually divide 30 by 10, right? To get 3. Okay, and remember we are solving a system, so now that I've found x, I need to also find y. So I just need to plug 3 in for one of my x's up here to solve for y. And I'm just going to use this one since I don't have fractions then. So I have y equals -2 times 3 plus 9. To get y is equal to -6 plus 9. So y is equal to 3. So my intersection point for that line perpendicular and line A would be at 3, 3. Okay, last thing I need to do is find the distance between those points. So I'm trying to find the distance between line A and point P. So point P has to be one of my points that I'm using. That's what it says in number 5. So we're finding the distance between point P, which is at 1, 7, and our intersection point that we found on line A, that's at 3, 3. Okay, and then we just have to plug those values into our distance formula. So again, we can label them x sub 1, y sub 1, and x sub 2, y sub 2, and then just plug those in. So we have the square root. X sub 2 is 3, minus x sub 1 is 1, that's squared, plus y sub 2 is 3, minus y sub 1 is 7, and that is squared. And again, you can just enter that right into your calculator, since most of you are going to do that anyways. To get 4.5. Okay, so again, very similar to what we did yesterday, right? Yes? Yeah? Okay, questions on this first example? No. No.
Couldn't you have just known it right away, though? You just plug in the slope.
Yeah, but if you go to the back, it's not gonna be a perfect number. All right, flip it over then. I want you to do the second example on the back. Okay, for that one, you will get fractions as your intersection point when you solve your system. Just a forewarning. Check to see for your fractions on your homework. It's not fraction. No. You do not get fractions on your assignment.
Is it already? Behind B. Yeah. Well, yeah. Behind B.
Oh, which point do you use? It doesn't matter, it just has to be one of these two. Yes, I can say, this is that. So that makes it 5.
Yeah, that's what
You're finding the y-intercept of that line.
So if you give your equation for the perpendicular line? Q? I got negative 2x plus 5, but that doesn't make sense because it has to have 2, 6. I goofed somewhere, I don't know.
Look at the line. See it.
Yeah, because it can't be 5 because it has to have
You have
2,
to
6.
change your slope.
Oh, gotcha. I have a question. How do we get to
You have to take the opposite principle of the slope.
that makes it?
Oh, you wrote 170. You use the point. Yeah. If this is positive, then the sign is negative. You just take the opposite sign from whatever direction.
Yeah. You got it on the first one?
It's this way, right?
Yep.
Okay.
You guys can write these ones as decimals instead of fractions if you want to.
For your intersection.
Just do it in decimals or
So it'd be 16.
like everything she did up there, I did not do. I just did in
Yeah,
decimals.
you have to, instead of 5 halves.
Oh my god. Is that point? Oh. Well, you just got it. Oh, it's so nice actually. Oh,
Yes. Yep.
It's 18 over 5. Wait, what answer do you do your
Wait, I'm so sorry.
So I'm from the wrong side. Right? So
If you finish going over that example, do the last question that's on the bottom there. You can talk to the person next to you if you're through the distance formula and everything else.
How would you find the shortest distance between parallel? 2.7? No. Just, what do you get? Yeah. $12.7. I got
You have to
2.7.
use the same.
6.96.
I got 2.7.
I got 2.7.
Okay.
I did something wrong then.
Then I
Am I
feel
not?
better.
I'm not. Wait, this mine's okay. Wait, come here.
Set it up right.
18, not 13. Oh, I just did simple math wrong.
That's what I do on tests, but can I have a homework assignment?
I do that right. I just have to plug it in.
Yeah.
And then, doesn't matter which one we, 'cause do I have to use the
You
same
have to
equation?
use this point and you have to use point P.
You have to use that point.
Yeah, so point P and point Q that you just found. Those are the
Doesn't,
two.
doesn't matter which one's first?
Nope. Nope. That was nice. You're gonna steal it?
I need to.
Popcorn. This probably tasted better if it was filled with popcorn.
Probably. Yes.
Moose one.
It's free.
All right, so I do want to just go over this really quick. If you are done, you can come and grab your pink homework assignment right here.
Grab me one.
Sophie, you must sit
All right, so you should have line A and point P drawn in. I'm going to skip that part because most of you had that already. So make sure you draw in line A and point P. The slope of line A, when you count, you do get 2/4, which is just 1/2. Okay, pick a point. I picked 2, 3. Doesn't matter if you pick 6, 5 or 2, 3. You're going to get the same y-intercept. So you do get a y-intercept of 2 when you plug those in. So the equation for line A is y equals 1/2 x plus 2. And as I walked around, most people did have that. So just plugging in your point for x and y like we did on the front, plugging in your slope to get our equation.
Oh, that's fine.
Number 3, we want to find the equation of the line perpendicular through point P, meaning I have to use point P, which is at 2, 6, and that is your x and y value. I also need the perpendicular slope, so I have to take the opposite reciprocal of 1/2. So the opposite would make it negative. Reciprocal would make it 2. Okay, then plugging this into y equals mx plus b, I would have 6 is equal to negative 2 times 2 plus b to find that y-intercept. So I have 6 equals negative 4 plus b to get b is equal to 10. So the equation of the line perpendicular is y is equal to negative 2x plus 10. Then I have to solve that system to see where they intersect. Okay, and I am just using these two equations. You do just set those equal to each other. Okay, and we'll solve for x here. So I'm going to add 2x. So that is just 4 halves x. So I do get 5 halves x. And then subtract 2 to get 8. Multiply by the reciprocal to get x is equal to 16/5. Okay, then you can just plug that into either one of your equations. Okay, so I would have y is equal to negative 2 times 16/5 plus 10. So I have negative 32/5 plus, get a common denominator here, that would be 50/5. So y is equal to 18/5. So my coordinate point is at 16/5, 18/5. Okay, and that's the point I need to use here for my distance. And this whole process is to find the distance between point P and line A. Okay, so I need to use point P as one of my points. So that's at 2, 6. And again, we just have to label those and plug them into that distance formula. So x sub 1, y sub 1, x sub 2, y sub 2. Okay, plugging those in, x sub 2 is 16/5 minus 2, quantity squared, 18/5 minus 6, quantity squared. Okay, and you should get 2.7 as your distance. Okay, on your assignment, you should get whole numbers for your intersection point. Okay, just like you did yesterday. So they shouldn't be fractions. Last question here. It says, explain in your own words how you'd find the shortest distance between parallel lines. Talk to the person next to you really quick. How would you find the shortest distance between parallel lines?
Exactly what we just did, except perpendicular lines to the parallel line.
Minus 16 and 3.
Yes.
Did you say we could or couldn't use decimals? Because I did.
Yes, you can
Okay.
use decimals. All right, so the shortest distance between parallel lines, you have to find the line perpendicular to both, and then you have to find those intersection points with that perpendicular line and your parallel lines. Use those intersection points to find that distance then. Okay? So you have to find the line perpendicular to both parallel lines. And find the intersection points. Then find the distance between the intersections.